Data flow diagrams in spreadsheet design. This presentation focuses on how data flow diagrams can be used to detect and improve structural weaknesses in spreadsheet design. Throughout this presentation, we'll explore their importance, their relevance in spreadsheet design, and insights from a research paper on this topic. Let's dive in. Data flow diagrams, or DFDs, are used to visually represent the flow of information within a system or organization. They show how data moves through processes, interacts with data stores, and communicates with external entities. Essentially, they provide a clear picture of how a system operates. Why are DFDs important? DFDs play a critical role in analyzing and designing systems. They allow us to see how data is processed and transferred within a system, which helps identify inefficiencies or redundancies. For instance, DFDs can highlight unnecessary steps, giving us the opportunity to optimize workflows. They also improve communication between stakeholders by providing a common visual language. By using DFDs, we ensure systems are not only functional, but also efficient and well-designed. DFDs are particularly important in spreadsheet design because spreadsheets are widely used across businesses for critical tasks, but often lack the rigorous checks and testing typical in software development. This can lead to structural flaws or smells, and the research highlights how DFDs can detect and communicate these issues effectively. They help improve the usability, maintainability, and reliability of spreadsheets by making weaknesses more visible. In essence, DFDs offer a systematic approach to improving spreadsheet design quality. We selected this paper because it presents an innovative approach to identifying weaknesses in spreadsheet design by using a software design artifact, data flow diagrams. The authors not only demonstrate how DFDs can be used for this purpose, but also show how they effectively communicate structural issues in a clear, actionable way. From this paper, we hope to learn two key things. First, how DFDs can be adapted and enriched to detect issues specifically in spreadsheet design. Second, we wanted to understand the types of structural flaws or smells that occur in spreadsheets and how they parallel similar issues found in traditional software design. These insights could provide valuable guidance for applying DFDs to practical problems in system analysis and design.
Our research paper included an empirical study. 4,223 real-world spreadsheets were analyzed. The researchers collaborated with financial professionals at Robeco. They used a tool called Brevise to analyze smells in the spreadsheets provided by Robeco. The main questions the researchers wanted to answer were, what smells are the most common? Do smells indicate problems with spreadsheet quality and integrity? And finally, are data flow diagrams an appropriate method to analyze spreadsheet smells?
To inappropriate intimacy, which is when two worksheets are dependent to each other severely with many formulas connecting them, making it hard to modify one worksheet without needing to modify the other worksheet severely, similar to having two classes in a software code that are similar. 3. Middleman, which is when a worksheet acts like a middleman where no meaningful process or transformation added, in which adds unnecessary complexity by adding extra layers of direction. And lastly, 4. Shotgun surgery, which is when one worksheet or formula is being referenced by many other formulas or worksheets. This makes modifying the original formula and or worksheets hard as it has a huge impact. Finding these smells can improve the quality, maintainability, and reliability of spreadsheets. In addition, identifying and finding a fix to these smells will reduce complexity, which improves the understandability. Traditional code smells, which is where smells originating from, focuses on class and methods. However, the inter-worksheet smells used in this paper focuses on the relationship between worksheets and formulas through metrics and thresholds. Spreadsheets are often created by users with little to no programming experience, which creates error-prone and poorly structured data, which is why finding these smells methods used with the use of DFD improves understandability for the users. This technique can be applied as it leverages the utilization of metrics and thresholds to identify flaws, allowing a consistent way to finding the smells. The data flow diagram provides a visual and interactive approach which is more user-friendly for non-programmers. This technique has ensured its practicality by 1. Doing studies on large corpus spreadsheets, which was from uses mentioned previously of having 4,223 spreadsheets. And lastly, 2. Doing 10 case studies on real-life application, which was through finance professionals at Robeco. When can this technique be used or become helpful, one may ask? This technique will be beneficial in business and finance settings where the spreadsheets are heavily used and tend to be complex, improving the quality of the spreadsheets for the professionals. A generalization of when this technique can be used are in settings where spreadsheets are utilized for data analysis and or modeling, as long as there are formulas and multiple workings involved, as the metrics and thresholds to find the smells are based on the relationship between these.
The authors effectively show that inter-worksheet smells reveal spreadsheet weaknesses, and that data flow diagrams provide valuable insights. Their conclusions are logical and are supported by both quantitative and qualitative evaluations. However, the study doesn't measure if refactoring the design of spreadsheets actually reduces errors, and selection bias is possible due to participants already being familiar with the tools. Overall, it's a solid and logical study, and we agree with the author's viewpoint.